Hi guys, and welcome to Engineer's Mindset. Today we'll start a series on calculus, starting with limit and functions of single variable. Limit explains the function, the behavior of function around the point. For instance, the limit as s tends to a of the function f of x equals L, meaning that as the value of x approaches a, the function f of x becomes the value of L. Alright, there are four methods of analysis of limit. The first is by direct substitution, where we actually put in the value or the point where the limit is tending to into the function. Okay, so when we carry out direct substitution method and the function fails, then we cannot try the next method, which is by factorization method. Now, a limit is said to fail when we have an indeterminate expression. Okay, and that is simply to say we have 0 divided by 0. This is called an indeterminate expression. When we evaluate a limit by direct substitution and we obtain 0 divided by 0, it means the limit has failed. The expression is said to be indeterminate. So it means we cannot use substitution method to determine the expression. So in that case, we'll try the next method, which is by factorization method. So take note, you always evaluate first by substitution method. If it fails, that's when you cannot try the next method. Alright, if we cannot factorize the function given to us, it means we cannot apply factorization method. So we'll try what? The conjugate method. If the function given to us also do not contain a conjugate, it means we cannot apply conjugate. So we'll try the last card, which is the L'Hopital's rule. And of course, the L'Hopital's rule can never fail. Of course, you can actually apply the L'Hopital's rule in virtually all the problems and you still obtain the same answer. So in this video, we'll start with direct substitution method. Now let's say we are given limit as s tends to 2 of the function f of x equal to 3x squared plus 2. Let's say we are given to evaluate this limit. So by direct substitution, we simply set x to be equal to 2. So you set s to be equal to the point it is tending to. Okay, so if you do that, it now means that the limit as s tends to 2 of the function, this becomes, in place of x, we are simply saying x is equal to 2. So this becomes f of 2 equal to 3x squared. X is 2, so 2 squared plus 2. And of course, this is 3 into 2 squared is 4 plus 2. Alright, so 3 goes into 4 gives us 12 plus 2, and this is 14. Hence, the limit as s tends to 2 of the function f of x is simply what? 14. Let's try another problem. Alright, let's say we are given to evaluate limit as s tends to 2, as s tends to minus 2 of the function x plus 8 over x squared minus 1. Alright, so by substitution, we simply set x to be equal to minus 2. So let x be equal to the point where the limit is tending to. Alright, so we have limit as s tends to minus 2 of the function. In place of f of x, we are simply saying f of minus 2 because x is minus 2. So this becomes f of minus 2 equal to, wherever I see x, you simply put in the value of x as 2, as minus 2. Alright, so we have x plus 8. So this is minus 2 plus 8 all over this x squared. So this is minus 2 squared minus 1. Okay, so we have minus 2 plus 8 over minus 2 squared is 4 minus 1. Alright, so we have minus 2 plus 8 is obviously 6. 4 minus 1 is obviously 3. So it means that the limit as s tends to minus 2 of the function f of x is equal to 6 over 3 is 2 is equal to 2. Thank you. Alright, let's try another problem. So let's say we are given to evaluate the limit as s tends to 0 of the function 5x squared plus 3x plus 2. Alright, by substitution, you simply set x to be equal to the point it is tending to, that 0. So we have limit as s tends to 0 of the function. In place of x becomes f of 0 equal to 5 by 0 square. So in place of x, we simply put 0. Okay, so plus 3 by 0 plus 2. And of course, 5 by 0 square is 0. 3 by 0 is 0 plus 2, and this is equal to 2. So this implies that limit as s tends to 0 of the function f of x is actually 2. That's it, guys. I will see you in the next video. We'll talk about factorization method in the next video, and I will get more problems on limit by substitution for you. All right, guys, I'll see you in the next video. Like the video if you find it interesting, and of course share to your friends for more subscribers. Thank you very much.